Very good afternoon, everyone. How are you guys? Thank you for coming to the CARPL Unboxing AI stage, where we discuss new ideas and talk about leading innovative solutions in the market. We're gonna jump right into that. So we have a very interesting panel. On day one, we have a Mammo AI panel moderated by Dr. John Lewin. Joining as panelists, we have Herman, who is representing MedCognetics. We have Nikos from DeepHealth, who is the breast AI product leader. And we have Dr. Ambika Seth, who is the medical director for Lunit. I'll be passing my mic to Dr. John, and have a great session, you guys.
Thank you very much. It's great to be here. I am the chief of breast imaging, and we are going to talk about breast imaging today, breast AI. And I want to start by giving everybody a chance to talk about their companies and what they do and sort of the overall scope. And then we'll get into where we stand in the field today. So we'll start with Ambika.
Hello. Yeah. Hi, everyone. So I'm a radiologist and medical director at Lunit. Our company's mission is to conquer cancer through AI. And as a radiologist, I am passionate about using AI the right way. I know it's a new technology. Many doctors don't trust it. So we are trying to bridge the trust gap. We have an entire ecosystem of products that sort of crosstalk with each other from, let's say, density, risk, cancer detection. And in the end, it's going to help you pick up more cancers. It's going to help the women and probably make life easier and better for everyone.
Go ahead, Nikos.
Nikos Gkanatsios, yes, I am from DeepHealth. I am the product leader for the breast AI. At DeepHealth, we're actually focusing on a vast number of AI solutions in population health, as we call it, which really extends not just to breast AI, but also prostate, lung, and brain. So we have a full solution for that. My responsibilities is mostly on breast health and really integrating all the possible solutions under one platform, what we call Breast Suite, to really help the radiologists to go through all the challenges that they have and try to accommodate not only accuracy and how to deal with breast AI, with CAD, but also workflow and how fast they can do reporting and anything that has to do with their day-to-day jobs.
Okay, my name is Herman Oosterwijk. I'm not a clinician, I'm an engineer. My specialty is connectivity. And I represent MedCognetics. Now, a really interesting story. MedCognetics is a spin-off from the University of Texas in Dallas. You might have heard about UTD. In Dallas, we have a big company called Texas Instruments. So there's a lot of synergy there. And so one of the PhD students came up with an algorithm for breast cancer detection. They spun it off as a little corporation, and then they called me, said, Herman, we need to figure out how to integrate it. So that's my background, MedCognetics. Very smart people, university, very tightly connected. We have a pilot site in India and several around the world, Brazil. So yeah, that's my story.
All right, it all sounds good. Everybody's got their own perspective coming from engineer with not that much medical background.
Medical physics and engineering.
Medical physicist with decades in the business, and a radiologist, also with a lot of experience in this area. So one thing that I've noticed is that AI is taking off, and it's going to be, there's no question, it's going to change all of our lives in every way, including at work. But I've noticed that even though there are more AI companies in mammo than any other area, and yet at our place in Yale, the non-mammo people are already using AI. They use it every day. They do cerebral hemorrhages and pulmonary nodules and pulmonary embolism, and yet we're not yet using it in mammo, although we're very close. So I'd say mammo adoption has been slow. We had CAD that showed us the way, sort of, and that took a long time, but that was for a while universally used. and then that's kind of faded away. And now we have deep learning. And so I'm going to ask you, and this format came from CARPL. They instructed me to do that. So in one word, you get one word. Okay, Herman and Nikos, we'll start with Herman. Good luck with this. One word. What is it? And it'll be good because you all have different perspectives. One word. What do you think Mammo AI needs to become successful?
Integration.
Okay, that was perfect.
I think he stole my thunder. Integration.
Okay,
Trust.
trust. Okay, those are all good. So we'll start. Let's start with Ambika. So what do you think it's going to take for radiologists to trust AI?
Yeah, so I think firstly they need to understand that computer vision and human vision are different things. Radiologists have been trained in a certain way to look at patterns, for example, speculations, microcals, right? We look at them, we know it's suspicious for cancer, but the AI does a pixel level analysis. So something that is very obvious to the AI might not be visible to us, and vice versa. Once we understand that, once we understand the science behind the AI, and obviously education plays a huge part in it, then we are able to trust AI better. Also, when we talk of Mammo versus other solutions like the brain and the chest solutions that you talked about, so when I'm looking at a chest X-ray, I know it's a nodule, consolidation, effusion, right? And the AI will tell me the same thing. When it comes to breast, again, we give a BIRAS category. The patient has to go in for further exams or a biopsy to confirm whether it's cancer or not. So we don't have the definitive answer. And even for the AI, unless if the AI is recalling a patient, she goes in for a biopsy, I'm not sure whether the AI is correct or not. So when it comes to Mammo, we have these extra steps of doing additional exams. Final ground truth is the biopsy. And that's why I think we need to follow up the patients, get the data, and then understand and start trusting the AI.
All right, Nikos.
If we remember, breast AI really got a bad rap in the past. And why was that? Because when it was really based on the machine learning, where really humans were developing equations and mathematical models to help AI back then to really figure out if there are speculations, if there are lobulations, if there are calcs. It wasn't very easy, and it was easy to really focus on calcs because it was very simple models to really perform. So it was great on calcs, but suffered on anything else. Why did it succeed? It succeeded because there was reimbursement. Everybody said back then that if we lose reimbursement, we'll lose CAD. Well, we lost reimbursement, but also AI didn't stop where it was back then, right? AI started developing new models that were based on deep learning, and with the deep learning, it really goes in a different level where now you don't really have mathematical equations built by humans. You have synapses that the actual AI is building for themselves, and by doing millions and millions of those synapses, you can really get the confidence build up of the system, and you can actually see that the performance is driven up not only on the calcification side, but also on the soft lesions. Why was that? It was because we can train the system with more and more cases. At DeepHealth, we have a repository of about 300,000 patients, the cases that we train for mammography. We have about 80 or so thousand cancers. And if you think about how many radiologists is actually doing in their lifetime, probably they don't really see 80,000 cancers. However, the radiologist is able to learn with a few cases and improve themselves with a few more cases. AI needs to learn with thousands of cases and improve with more and more thousands of cases, where we actually strive to do that. And I guess one of the advantages of, or one of the opportunities in DeepHealth is that we do have RadNet as a network where we can get a lot of data to train the AI. So trust is already there because the new technology of deep learning, enhanced with a lot of data, can really perform better on the let's say sensitivity side, still lags behind on the specificity side. If we fix that, then we will have a little more trust as well.
So the reason I think that Mammo AI was just the first, because we were used to CAD, We knew what CAD was all about. And I think, by the way, that having CAD originally was both a curse and a blessing. I think the curse would be people had a bias because they know all these false positives. So is it AI really going to be better? But the blessing was that people know about it, and it was all kind of integrated. So we have structured reports, for example, that people know about, right? So, and we know one of the big differences between CAD, traditional CAD, was static. So the algorithm that we used was probably the one in 1996, where first filed, right, the first CAD FDA approval. And there's a tremendous opportunity. AI for breast imaging is only going to be better because there are tens of thousands of images, day in, day out, gone for the algorithm. So I have absolutely, no question that eventually AI breast imaging is going to be surpass anything we know in CAD. It's just a matter of collecting the data, training the algorithm, and AI will become only smarter.
So you've all said different things about trust, but what exactly? So let's just go back for one step. What about data? What kind of study is the best study to show that AI really works? And we could start with Herman, only because he's there. But
actually, to be honest, I don't know because I can't keep up.
Fair enough.
Because every day is another study. Okay, we do this and that, and it's a little bit better, a little bit less. And then there's a study from Sweden, and one from the United States, and then from India. I can't keep up. So what I do, I listen to the clinicians, what they think. So,
all right, go ahead. And you're absolutely right. That's what we see is that there's lots of studies, and AI always does very well in all these studies. And can we trust them? I've read a lot of non-breast AI studies. They're all, the IEEE is full of them, and all these archives are just full of AI algorithms. They test them, they work. But so can we believe them, and what's it going to take?
So studies are really tricky. Why are they tricky? Because it depends how they are organized. There are different scenarios that you need to test, right? If you're in Europe, you're testing maybe on 2D. If you're in the US, you're testing on Tomo. These are completely different modalities. The performance is different. Also in Europe, you may be testing to see if you can remove a second reader. So the outcomes will be different versus in the US, where maybe you're looking to see if you can improve the cancer detection rate. One thing that I believe that is needed, no matter which the outcome that you're seeking is or what you're trying to evaluate, is the type of study has to really be, in my mind, and a DeepHealth's mind, a real-world study with real-world evidence. So you have to really go into the clinical centers, organize something that is extensive, and focus on bringing as much data in. We see a lot of publications with 100 cancers, with 2,000 patients. I mean, if you check 2,000 patients in a screening environment, you're looking for 10, 15 cancers. You cannot get any statistics, and you cannot believe anything of that, right? But if you do a 600,000 study with, 2,500 cancers, then you do have the power to believe what the study is providing for you. So depends again on the environment and the type of study, and depends on the population and really how you generalize the study to get to use something that you really trust and believe.
Yeah, I agree with Nicholas. And adding to that, I think one of the best studies would be the prospective randomized trials, because we are doing that in the real clinical situation. We are not sort of interfering in any way. We are not tampering the study design. So it's as close to real world as possible. Having said that, like at Lunit also, we have done prospective studies with 200, 300,000, 600,000 women. But all these studies, we need to see whether they actually lead to long-term benefits in terms of mortality or morbidity or not. And I think as a radiologist, that's a very important point, because just picking up cancer is not sufficient. If we are picking up, let's say, early stage cancers, DCIS, not aggressive cancers, that's not really going to help in the long term. So for that, I think we can concentrate on the interval cancers, because these are the aggressive cancers. These are actually surrogates for mortality. And if we could look at studies that bring down the interval cancer rate, I think that would be great. And we have worked with Mass General in a study focusing on interval cancers, and have seen that our product can reduce the interval cancer rate by almost 30%. So these are aggressive cancers, they spread really fast, and these are cancers that are not picked up by the radiologist during the screening round. So just imagine picking up 30% of those cancers earlier. That would mean we can save so many more lives.
All right, nice answers. So let's talk about where AI is today. So you all have an installed base. Well, you two have an installed base. You have a small installed base at MedCognetics. What makes somebody move to AI for mammo? What's the most important thing? Is it sensitivity? Is it having a strong negative predictive value? Or what makes the value in AI? All right, let's start. And Nikos, you can also, while you have the mic, you obviously have RadNet and you have a big base that you can test things on. Have you noticed or checked for anything related to interval cancers or long-term outcomes? So
Yes.
go ahead and start with that, and then you can move on.
Actually, when we filed to the FDA, we have two groups of cancers. We have the index cancers and we have the non-recall cancers. So we test on both. And the key is that the non-recall cancers, which means that the radiologist didn't really call them, we have a sensitivity of about 80 to 85% there, which means that, as Dr. Seth mentioned, if you use AI, you have the opportunity to find things much earlier than the radiologist, or at least call them earlier, or sensitize the radiologist to trust AI and call those things early. So that's very, very important and significant.
So that's good. That's great. But with having this big installed base at RadNet and being able to look at all the data, do you have anything perspective going where you can see whether interval cancers, which are hard to track because they don't always, they won't go to a freestanding RadNet center may never see the interval cancer. So it requires some research and linking to tumor registries and all kinds of hard things, things that the Mass General probably can do because they already are tied to the Massachusetts Tumor Registry. But anything like that going on? Yes,
actually, we just finished that. As I said, we are blessed to have RadNet as part of the network. And we just finished a 610,000 case prospective study on the RadNet, I think 400 plus facilities that we used to study. And there were about 2,400 cancers there. And the cancer improvement detection rate was about 22, 23%. And those were really on the cases that the radiologist dismissed and the AI picked up. And it was retrospective review as almost like a second reader. And those, the performance there increased by 23%. So, yeah.
All right. So back to the original question. What makes a customer do AI? What are they looking for the most?
It depends. It depends on the region, right? For the US, what do we have in the US? We have tomosynthesis. It's challenging to read tomosynthesis. You have 60 slices that you have to read in 30 seconds or so, and you have to compare with priors. So in terms of sensitivity, specificity, everybody expects that AI will perform. They don't really untrust it anymore as they used to when it was the old machine learning. So they trust the performance of that, but the question is, how can I use AI to synchronize my workflow or really pick up the cases that I need to read in the morning where, let's say, I have more of a clarity in mind? At the same time, can I read faster? Yes, you can read faster if you combine Tomo with AI because you still read, but at least you have a safety net at the back of your mind that when you use AI, even if it gives you 1 or 2 false positives, you know that you didn't miss anything because sensitivity is higher than your sensitivity at the end of the day. Not that it doesn't miss cancers, right? AI still misses cancers. But at the end of the day, you know that you have a safety net and you can read a little faster and you can improve your productivity, especially if you combine it with AI helping you in the reporting part of it and AI helping you in organizing your cases for you, etc. So those are the pieces that we focus on to make the radiologist more in tune into using AI versus I just want some sensitivity and specificity, which doesn't really mean anything because the radiologists will never really say that AI is better than they are anyway.
I might dispute that, but okay. But so if we were to summarize that in 3 words, it would, no, 3 words would be sensitivity and integration. That seems to be the 2 you were focused on. Okay, Herman.
So I think what you're asking, what are the critical success factors, right? So I think one good case study I've seen in Delhi when I visited a deployment of MedCognetics. And Delhi, I don't know if you've ever been in Delhi, but Delhi is notorious for traffic. So it takes at least an hour and a half, or not more, to get to our office. So the radiologist, she, in the morning when she's in traffic, and of course, she has a driver. We just talked about it. Everybody has a driver in India. But anyway, so she looks at the list, and so she does triage. That's a big savings. And that's something we didn't have in the past. So basically, there's a list of, things that. So when she comes to the office, she already knows who needs to be worked on. So triage, I think, in certain circumstances, maybe Delhi and everywhere that people spend a lot of time in the car, it's a good solution. But I talked with another radiologist last week when I was volunteering in Africa. There was a Swiss radiologist, and so I talked about AI, and she said she kind of has this curse and blessing, because it's more work. But she says the bottom line is, and she used CAT, the bottom line is they detect more cancers. So I think the 2 things. We know we can improve clinical, we can clinically do a much better job, right? And if we can also improve, the false positives, and it's also if you improve the integration, make it really easy, I think it's going to be a no-brainer. But it's just, it takes time. It will take time, but I'm confident, when we talk maybe next year or 2 years or 3 years from now, we're sitting in maybe the same booth and say, okay, well, we have made some major strides, and I know it's going to happen.
Yeah, so we talked about AI that picks up cancer, right? I would like to speak about AI wherein it can help us automate tasks and do certain tasks that humans cannot. For example, when we talk about image quality, PGMI, right? So if AI can help us do that, if it can help the techs know whether it's a good enough mammo, whether they need to repeat that or not, I think that's a huge add-on, something we are doing. Also, when we talk about things such as, let's say, density, and we know that we do a visual inspection, but the AI can do a volumetric breast density assessment that's much closer to the actual ground truth than the human eyes. And we know that density affects the chances of cancers. It can also mask cancer. Plus, in the US, we have a density rule wherein whenever it's a dense breast, we need to inform the woman. So having these tools tell us the accurate density, something that our eyes cannot do at times, that would be a real add-on. And lastly, when we talk about things such as image-based risk, now that is something that human eyes cannot do, irrespective of the training, the amount of training that we get. So if the AI tools can look at the texture, the patterns, pick up those early subtle signs and tell us that, okay, this woman has a higher risk of cancer in the next 5 years, she goes in for a supplemental MR, and if that's approved, she gets reimbursed. There's more revenue. We pick up more cancers earlier, so everybody's happy.
You don't want to say anything about the traffic in Delhi?
I don't think everybody's going to be happy about that, so I'll leave that
All
out.
right. So Dr. Ambika used to live in Delhi, and so she's well aware of the traffic. Yes, and she used to read mammograms on her way to work, I'm pretty sure.
With a driver. So.
With a driver. All right, so we've talked about many things here: suite of applications, usefulness, how important integration is, and we talked about trust. So, and the adoption of AI. Once it's adopted, get that one away. Maybe that's the key. Once AI is adopted, how are we going to keep an eye on it? How do we monitor it and make sure it's not drifting? How do we know when we change mammography units, or even the mammography unit changes software? How do we know that we're still performing? What are we going to do to monitor and make sure it's still working as well as it did?
Well, getting it approved is the first step, right? And when you get something approved, you really know very little about the final performance of the system in the real world. You really have to monitor it. And I think it is the responsibility of the vendor to monitor the performance of the system. And now it depends on the infrastructure and the integration, how well we can dig into the different install base that we have and get the information back and see if there are any drifts. Because if, let's say, we follow through of how many false positives per case we see every day, if we see a shift on that, and it's very simple to do that if you own the platform and you have the integration, then you know that something changed in a site or something changed in a manufacturer of, maybe they changed the image processing. So it's really easy to follow up. We just have to be cognizant of that and doing it, because there is certainly no assurance that the day you release, the performance that you have there will continue to be the same a month later, a year later, 2 years later. Of course, 2 years for AI is too long. Everything changes in 2 years. But definitely the manufacturer needs to follow through and needs to put the infrastructure. And the key is to do it in real time, where they have the infrastructure on the platform, they can take advantage of that and get the feedback right away.
And you're talking about feedback from the radiologists that they're seeing that things aren't the same, or what do we have like hard data wise that you can provide in? You can't do it in real time. It has to be retrospective after a year or more, unfortunately. But what do you say?
I'm saying that you can do it in real time and you don't have to depend on the radiologist, because in a lot of cases, the radiologists, they are very adapt to situations and they read whatever they get because that's what they have. They may complain to the sales force, etc. Well, I have these cases that I don't agree with, but they don't do it often. Real-time monitoring is basically, if you own the platform, you can really watch your algorithm perform, and you can see how many high scores you have, how many medium scores you have, how many marks per image you have, because you know how many cancers you get. If you have, you can take your specificity. If you see that from 75% being no marks, you go to 60%, something is going on. And you can get all that feedback in real time from your systems. And that's really the key, to put the infrastructure together, to monitor your systems in the field and react to them as soon as you see something happening, because you know that something is not going right. And it may not be your algorithm, it may be a change that happened in the field.
Yep, go ahead.
I like your perspective from a vendor perspective, but I'm really big on governance. Every hospital has a governance committee, otherwise they shouldn't be allowed to have AI in the hospital. And so that's a key job for the governors, not only the front end, like what AI we're going to do, or do we try it out first, and how we're going to deploy it, and da-da-da-da. But I think, the back end part, monitoring it is critical, governance. And actually I had to really think, there's another story. I'm big in DICOM and, image quality, whatever. And when they get these monitors coming out first, there was a radiologist, and I think he was in Seattle, that noticed after a year he couldn't see the cancers anymore. I said, what's going on? And then we said, well, did you calibrate your monitors? What do you mean calibrate the monitors? Do they need to be calibrated? So I almost see like a similarity or a precedent, like we monitor image quality. We also need to monitor the AI performance, right? So we know how to monitor one thing, just a matter of doing the other thing as well.
Yeah, so when it comes to monitoring, we have something called an insight board that basically gives you live alerts. It gives really nice graphs. It tells you how many cases are normal, how many are suspicious of cancer. And you can set it to go off when, let's say, the proportion of normal cases or the proportion of cancers crosses a certain limit. So you know that there is a change in the AI performance on a daily basis. You can get reports, you can get alerts, like monthly reports, quarterly reports, it's all there. And just to add to what he said, clinical feedback is also very important. So we have these clinical discussions with the radiologist apart from the technical graphs and the boards. wherein the radiologists come to us and they say that, the AI was performing really well 3 months ago, but then we changed our machine. We changed certain parameters. For example, the sharpness increased 15%, the brightness and the contrast changed. And now we see that the AI is not picking up those many calcifications. It's giving false positives. So we go back, work with the hardware company to figure out what went wrong. And we have realized that these are factors that do affect the AI performance. So I think one part is the technical monitoring, and the other part is to talk to the doctors because they are the ones who are using it on a day-to-day basis. And I was surprised that they could actually, see the change in the performance. And they told me that initially it was picking up more cancers, now it's not.
Very interesting. So what do I, as the head of a breast imaging department, how do I decide between the various companies? There's so many products out there. They all perform well in terms of sensitivity. They have similar ROC curves. What can I do? What's the best way for me to start when I am looking to buy an AI product? There you go. Looks like Nikos.
It all depends what you're looking for, right? The areas that you want to improve. It may be your detection rate is not really up to speed because you have mostly general radiologists instead of specialists. Or it may be that you don't want your radiologists that are paid so high to really spend a lot of time on the reporting part, and you want the AI to be part of the reporting so that you can accelerate that. Of course, sensitivity and performance and accuracy and trust, that's a given, but I think everybody offers similar things in terms of performance of the algorithms, right? Because they're all well trained, they're all well curated. So that part is a given to me. It's really the integration, it's the reporting, is the customization, the flexibility, and the workflow that it can offer with the different tools and the different options that it has. So as a head of the department, you have to evaluate all these parameters and where your need is and focus on the companies that offer exactly or tailor their offering towards your needs.
So, first of all, I would make sure that you pick an algorithm from a company that has customers close by. If you have an algorithm that was developed in, and not to pick on China, but let's say in China or in South Korea, and they have very few deployments in the region that you are, we don't know. You don't know how the training data is that they use, right? So I would look at the local performance. And second, I personally think that we're focusing as an industry a little bit too much on cancer, breast cancer. And if you think about breast imaging, it's just not breast cancer. There is arterial calcification, right? And it's like almost a little bit my soapbox. There are more women that die from heart disease than breast cancer, right? So I think breast imaging could be such a window into the overall health, and much more than just cancer than all the other things. So I would look for a company that does not focus solely on that one particular disease, but look at that body part and say, what's going on? So breast imaging will be, representing what else can be on with a woman.
Yeah, so to add to that, I think the company should have a strong technical team because integrating the products into your workflow should not be a burden. Radiologists are used to reading a certain way, right? And they don't want to add clicks to their pathway. They want it to be as simple as possible to reduce the number of clicks. So the company needs to have a really good technical team that's able to help with the integration. After that, specifically when we talk about Mammo and DBT, we know that DBT, these are heavy files. So it takes time for the images to go to the AI company for the results to come back. So an important consideration should be how long it takes for the result to display. Because as a radiologist, I don't want to sit in front of a screen and just wait for the AI results while the patients are waiting. I want it to be really quick so that I can triage the patients. So I think that's really important. And lastly, I think customer success teams Dedicated customer success teams are also very important because, as with any technology, AI, when you deploy it, there will be problems. So you need teams out there to help you any time of the day to ensure that everything is working smoothly.
So just to follow up, so what do I do to make sure I'm getting all that in my product before I install it? Do all of you offer a chance to install it in a test period? And how much infrastructure work is that? How hard is that? Is there an easy way for me to evaluate?
It is easy and not easy. Why is it not easy? As Dr. Seth mentioned, DBT files are huge, right? So if you have a database, a data set that you can provide to the vendor, we can do the run and you can do the analysis, you can see the results because you also have the truth. But it's not a simple thing to do. Now, can we install and you can run it for a couple of months and then decide if you like it? All of these things are possible, but they take a lot of time, especially if you have cloud solutions, etc. Then you have to have multiple parties involved. So it is a little difficult to really do trial runs. I will go back to what Herman mentioned. Really, before you go with a certain vendor, you have to look into the long term and see if you are to marry with this vendor, right? How does the long-term situation look like? Am I going to be happy for the long term or it's going to be just a little bit? Because you're doing an investment. And if you're doing an investment, you have to make sure that the vendor is going to really produce results for you. Now, it is really up to the customer to do this research and to look into the future and see what the future pathways of the different vendors are and if they are a good match for what they want. And maybe at the current moment, everybody is equal, but maybe in 3 to 4 years later, one vendor really produces completely different results and completely different offerings and value proposition. So maybe that's really the way to do the choice instead of testing for a couple of months. And then, because everybody will also perform the same way. When you test, you do test integration, but it's very limited, and you're looking into sensitivity and specificity, etc., which everybody is really about the same.
It's an interesting question because we're the booth of a platform company, and when I sometimes talk with a hospital, I say I have this really represent this company that has this really nice algorithm for breast cancer detection and breast imaging. And then the first thing they usually say, well, you should run on our platform because we're only going to target you if you run on our platform because we're not going to spend 6 months security, penetration testing, this and this and this. So I think that's where our platform has a big role because it provides the infrastructure, not only for breast imaging, for all the other applications, because who knows, there might be 10, 20, 30, who knows how many AI applications we're going to have, right? So that's my answer. I think a platform is really, really important.
So I'm glad you mentioned that because otherwise I was going to have to. Because yes, this is a platform company, and they are not paying me anything for this, by the way. But we do have platforms where I am, and they do make integrating new AI tools easier. So yeah, what's the role of platform integration, would you say? Nikos, you can say, and you don't have to say it's critical just because you're sitting in their booth.
No, it is important because you need avenues, and sometimes the avenue to get AI into your department is very costly and time-consuming. Penetration testing, all the security stuff. You may just spend 6 months trying to figure it out, and then 6 months in testing, and then legal contracts and all of that. So it may delay you. If you already have a platform in your hospital for whatever other reason, right? Then this platform can be a gateway to get another vendor's AI introduced very quickly with a simple integration between vendor and platform. And then you already have the infrastructure and you can already take advantage of that. And as things progress, new AI offerings that are happening, they actually become part of that platform. And then you can actually without having to do any extra tasks. It's just a matter of signing and saying, I'm going to pay for the next AI now, etc. Right? So that's also the philosophy in DeepHealth. We have our own platform. We are also working with CARPL to really connect the two platforms together. So what we may not offer, we actually get it to our customers through another integrator like CARPL.
Yeah, I agree with you. So having a platform and bringing new AI onto it would make life simpler. You don't have to go through security and everything again. But when we talk about like big public hospitals, like Mass General or even Emory Brown, your hospital, these people like to do their own research when it comes to different AI vendors. They have the resource, they have the data sets. So having those data sets and the strict ground truth is really important for validation. And these institutes can afford to do that. That's why they go for it. But let's say it's a large radiology group. They don't have the time. They quickly want to get a new AI. In that case, I think using the platform is a great option.